What is up, everyone? Welcome back to the Intro to C++ for Games series. Today we're going to talk about while loops. While loops are kind of like the cousin of the for loop, where with the for loop what we were doing is we're able to run a very particular piece of code multiple times over and over again until this middle condition right here is met, where our I is less than or equal to 10. And that's great and everything, but there's going to be times where we don't exactly know how many times we're going to want to iterate through this code, right? So one example, which we're going to talk about right here, is going to be with stamina systems and just different stuff like that. So right here, I'm going to switch over and I'm going to show you this clip that I have from Fallout 4. And if you look at the bottom right hand corner of the screen, we've got an AP meter. So I'm going to start it. And while I'm running, you can see that the AP is going down. So that bar is going to be ability points, right? And so while I'm running, that meter is going down. And when I stop running, it goes back up. Basically, what we want to do for when we're depleting the bar is we want to say something like, while the player is not, when we want to replenish the bar, right? We want to say, while the player is not sprinting, then we want to increase the ability points, right? So I'll go ahead and put this video away now. And yeah, basically, that's what we're going to do, is we're going to say, while the player is not sprinting, then we're going to go ahead and increase the AP, because we don't want it to keep increasing past 100%, because then we've got issues, right? So what I'm going to do is I'm going to get rid of all this stuff right here, and I'm going to create a Boolean, and I'm going to call it is sprinting, and that's going to be set to true for this demonstration, or this is going to be set to false rather, because we want to replenish this this AP meter. And so yeah, we've got the player is not sprinting, and then I'm also going to have a float, and I'm going to call that stamina. And stamina, I'm just going to set it to 0.5 just to start this off with. And what we're going to do is we're going to go ahead and say while the player is not sprinting, so while is sprinting is equal to false, we're going to increase stamina by, I don't know, 0.1. But if we go ahead and actually run this code, let's take a look and see what happens. Nothing actually happens. And that is because what we have done is we have just created for ourselves an infinite loop. What do I mean by an infinite loop? Well, if we take a look at what we did, we just said, well, while the character is not sprinting, then we're going to keep adding stamina. But we never set stamina or is sprinting to true. So what we did is we just created an infinite loop for ourselves, and that can happen very, very easily, and it's something that you're going to want to watch out for when you're writing loops, especially while loops. It's very easy to get into a situation where you create an infinite loop. A lot of times, like if you're in, I don't know, for example, Unreal Engine, and you get an infinite loop, a lot of times the engine will crash, and that's not a good thing for you as a developer, and it's not a good thing for your potential consumer or player. So we can do a couple things about this. The first way is to create some sort of way that we can change this back to true, but then we've got different situations. But I think what it is, the craziest thing that we forgot to actually do is we forgot to set an upper limit for the stamina. So in this case, we want the max value for the stamina to be equal to 1, right? So what we can do is we can come over here and create a float maximum stamina, and that's going to be equal to 1, right? And then we can go ahead and actually say, instead of while this, we say while stamina is less than maximum stamina. So while the stamina is less than maximum stamina, then increase the stamina by 0.1. Well, this is going to be nice, but this actually doesn't take into consideration if our player is sprinting or not. And that's where we're going to come into a different operator. So inside of these for loops and while loops and if else statements, we've got, the keyword, and then we've got this parameter right here that we say. And this parameter right here, for example, is stamina is less than maximum stamina. But we can actually chain these together. So if I put parentheses around that, and then I say and, then we can check for two different parameters at the same time. So right here, what I have is basically I just said, while stamina is less than the maximum stamina and is sprinting is equal to false, then we'll increase the stamina by 0.1. And this is going to be something that that is tremendous for us as far as writing readable code and just doing other, more complex things where we can actually chain together these statements. The biggest two that you'll see is you'll see the and, which is 2 ampersands, and you'll also see or, which is going to be 2. I don't even know what this is called. If you go, it's most likely going to be under your backspace bar, and it's the little backslash, so this guy, not the one that makes comments, the other one. And you hit shift, and you hit that button, then you'll get the or symbol. So the or, if either one of these statements is true, then it's going to fire off this, this code down here. So this one could be false and this one could be true, and the or would run. Or this one could be true and this one could be false. But they could both be true and it would run. But as long as one of these is true, then it'll run. But with and, both of the statements have to be true in order for it to run. So what we have is while stamina is less than maximum stamina and is sprinting is false, then stamina will be increased by 0.1. What we should also talk about is this maximum stamina. We don't want this maximum stamina value to change in our case, because 1 is going to be our upper limit. 1 is going to represent 100%. So if I wanted to right here, I could actually go ahead and change this maximum stamina, right? But that's not what we want to be able to do. So what I'm going to do is, with this maximum stamina value right here, before we tell the compiler that this is going to be a float, we're actually going to say const. So what this is going to do is it's going to say that this value right here is not going to be changeable at all. We won't be able to change it, and this is why we're getting an error message down here. If you look at it, it says expression must be a modifiable L value. Don't worry about what L value means, but basically what we did is we said we are not going to be able to change this value. And what a lot of people will do is they'll make this capitalize. So you'll probably see that a lot. So you'll see max stamina is going to be capitalized, and capitalized variables are generally going to be constants. And that's what we did here. So we just use const real quick to make sure that this value is not going to be able to be changed. So we can expect it to work exactly the same as if we put 1.0 right there. But the benefit of putting a value there a variable rather than just the value, is that we can actually go ahead and use this, max stamina value in other places in the code as well. And we always know exactly what we're talking about. So maybe if we're taking away from the meter like we would be if we're actually sprinting, then we could also have a min stamina value, and that min stamina value might be 0, and that value is not going to be changeable. So what we want to do is we want to have some sort of min and some sort of max, and that's going to be a nice easy way for us to keep track of that. So yeah, if we go ahead and save this code and run it, I'm going to put a breakpoint right there. I'm going to go to the local Windows debugger, build and debug. It's looking for a value called ability points. I'm going to look for stamina instead. And right here it's at 0.5. And I'm going to continue. And the code is going to run through. And then it's going to reevaluate this statement right here. And then after it reevaluates that statement, it'll actually run the code. So this is where we are right now. Hit continue again. And it does it again. And again. And again. And then one more time. And then it's done. So as you can see, we have while stamina is less than max stamina, and because we want to test for both of these at the same time, is sprinting is false, then we'll do this. And just to show you that this and actually works the way that I claim it does, is I'll set is sprinting equal to true. So what that means is this will be evaluated as true for the first few go-arounds of this loop, but this will always be evaluated as false. So when we hit the breakpoint, we should expect that nothing happens after that. So I'm going to go ahead and run the code. We're going to hit this breakpoint, and when I hit continue, we don't continue going through that loop and looping it over and over, because both of those statements have to be true in order for the code to run at all. Now, this isn't something that you want to do for this example, but here I'm just going to show you that the OR works the way that I claim it does as well. So either one of or both of the statements should be evaluated to true. So that means is at least one of these two statements need to be true in order for it to run. So I'm going to go ahead and run it through our debugging again. So we're going to go ahead and, yep, it's going to keep looping through. It's going to keep looping through until it's done. Oh, but it's not going to be done because both of these don't have to be the same value, right? So here we've got stamina is less than maximum stamina. And you say, okay, wait a minute. At that point, 1.7 is way bigger than 1.0. So that's evaluated to false, but our player is still sprinting. Or our player is still not sprinting, rather. So only one of these values need to be true in order for the code to run. And this is going to give us another infinite loop. So like I said, it's very easy to get caught up inside of an infinite loop. But if we go ahead and say that this is going to be true, then what we're going to do is until our stamina reaches our maximum stamina value, this is going to be able to run. But this is going to be evaluated to false the whole way. So once this value becomes false, then the code will stop running. We'll go ahead and run it through the debugger again and see we've got 0.5, 0.6, 0.7, 0.8, 0.9, 1, and then both of our statements then become false, exiting us from the loop. Hopefully all of that made sense. We talked about the while loop, how it differs from the for loop. We talked about joining multiple statements together, and we could actually even just keep going. So we can say and then or, and we can keep going on and on and on and creating long chains of logic. But yeah, so that's what we talked about. We talked about the while loop. We talked about chaining together our statements inside of these loops, because this does work for while loops, it works for loops, and it works for our if and else statements. So we can actually say if our stamina is blah 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 and the sprinting is blah blah blah, or rather, and this will work the same way. So both of these are going to be evaluated to true, so it's going to run through it once. And then if we do and, it'll be the same thing. Boom. So we talked about those two things, and we also talked about const. What we want to use const for is we want to use const when we know for sure that we're not going to be changing the value. So if you're looking for something like, earlier in the series we've talked about pi, and pi is equal to 3.14159. You don't want some tired programmer, because that's what it is. People get tired and then people change values weirdly. And somebody's going to set pi to 2. And then all of the rest of your math dealing with pi is going to be way wrong. So what you want to do is you want to say const, because we don't want this value to be changed ever at all. And then when the programmer, who is really tired at 4 in the morning and is writing code, comes through and tries to say, oh, pi is equal to 2, it's going to throw an error message and say, hey, you can't do that. It's not going to do it. And then we can also come over and try to build it, and it'll say there's an error. And then it'll say pi you cannot assign to a variable that is const. You can't change that value because it's const. Hopefully we learned something here today. If not, then let me know in the comment section what I can do better. If you liked it, hit the like button. If you disliked it, hit the dislike button. And I will see you all in the next one.